So this is again Math 30-1. We are looking at Lesson 2, Reflections and Stretches. So this video is going to focus on reflections, and I will do a second video on stretches. So when we think of a graph and its reflection, we have to have an axis or a line that we reflect the graph in. And so we're going to focus on reflections in the x-axis first, and then we'll look at reflections in the y-axis. So I want you to go back to when you were a kid, and if you might have put a bunch of ink on some paper or paint on paper and then folded it up and created sort of that butterfly effect where you had wings on both sides or dots of color on spreading out on both sides. And that's an example of a reflection where you folded the graph or the image up along a line and you create a reflected image on the other side. So let's first of all create just a Cartesian plane. We're going to first look at reflections in the x-axis, and we'll do that by putting a point on the x. So we have this point, we'll call it point A. And so imagine that we can fold this graph along the x-axis, and this point A is 1, 2, 3, 4, 5 units above it, above the x-axis, and we've got 1, 2, 3, 4, and so it's has coordinates of 4 and 5. And when we reflect it, that point gets moved down the same number of units that it is above the x-axis. So 1, 2, 3, 4, and 5. So we now have our reflected point A, and I'll just indicate that it's a reflection by calling it A prime, and we can see that we have 4 and -5. And so all that happens is that rather than having an output or a y value or a function of 5, we now have a function that's -5. Okay, let's look at another example, and I'll create a second. Instead of just a point, we will look at a function. So initially I'm just going to take a few minutes to draw the function, and we'll pick some points. Let's just, doesn't have to be random. There's an image similar to this in your graph, in your textbook on page 16. It's not, I haven't made it precisely the same, but it's approximately the same. And so we are just connecting this up, so we've got a function. And we'll call this function f of x. And we're going to reflect this function in the x-axis. So again, it's like bringing it down below. So I'm going to label each of these points A, B, C, D, and E. So in this function, when we reflect it, A now moves 3 below the x-axis because A is 3 above, so we have, and that's A prime. And then we have B, which sits 1, 2, 3, 4, 5 above, so B prime is 5, 1, 2, 3, 4, 5 below. C is 3 below, and here D is also 3 below. And then notice that E sits on the x-axis, and so it's neither above nor below, so its reflection is in fact the same point. So when we go to connect these, and let's just try that again. I'm going to These are reflected points, or the primes, like so. And so we can see that they sit. The shape hasn't been changed, but the orientation has changed. So it's no longer looks like a going up a hill and then down. It looks like we're going down and then up. So the orientation has changed, but the shape itself has not. Now, if we had another type of graph, let's go and we'll do one more example here. And we'll just scroll down, create a third Cartesian plane. Oh, and I guess we'll make our Cartesian plane red this time. Oops. And what I want you to notice, and what we haven't done as of yet, is we haven't had a point that was below the x-axis. So let's actually graph a function that sits below the x-axis, and I'm just so if we think of a quadratic function that has, for instance, f of x is equal to x plus 2 squared minus 3. Remember, if you recall, that this gives you a vertex of 2 and negative 3. So we go, oh sorry, that would be negative 2 and negative 3. My mistake. 1, 2, 3, and down here. Okay. And essentially this goes, it's going to cross here. So out 1, up 1, and just give me a second. Out 1, up 2. Out 3. And up. Okay, so it looks sort of like this, approximately. Okay. And if we reflect this in the y-axis, what that means in my reflected function, so I'm sitting 2 below, so now the vertex of my reflected function is here. Notice that I have invariant points again, where the graph or the function sits on the x-axis. And now I've done not a great job of the shape of a quadratic, but we have that shape. And so if your points are below, then the reflected point is above. If your points are above, then the reflected point is below. So this is f of x. Now, if we think of this in terms of the function, what we've graphed here is the negative f of x. So when you have y is equal to negative f of x, this negative indicates a reflection in the x-axis. So in this case, our reflected graph would be negative x plus 2 squared minus 3. So the whole function, this is what our function is, all of that is negative. So our reflected function, it simply takes on a negative value in front. And so that is our reflection in the x-axis. We can see that the function it's the opposite of the function, or the negative function, where that negative exists outside of the function. I'm going to stop here, and then we'll do a second video on reflections in the y-axis.